there anything? And an option is not, no, I don't want to know nothing. Can I go home or now? I don't want to know a damn thing about these people. No? Yes? No? Yes? Average age. Okay. That's a nice, easy one to talk about. And nobody else is saying anything, so you got the floor there, dude. I like it. I got to hire somebody to do this for me. Okay. So there's a group we want to say something about collectively, right? And we call that, and who are these people we want to say something about? It's obviously what? What's the group we want to say something about in this scenario? Okay, I like it. That's the word we use. What is the group? All gross font students, right? So our population is all gross font students. I love it. How many different things could we say about them? I mean, you said age, but it could have been almost anything. The average shoe size. What percentage of them like to eat chicken? Or, whatever. You guys with me? What? No? Some of you guys are looking like, what is going on? All right, I'm trying to ease this in. All right, so the population, the definition of it, you can see how poorly I write. The definition of it is the collection or the collection of items that you want to say something about, right? The complete collection you want to say something about. Items or people, obviously. Now, that's worse than normal for me, sorry. We can't talk to every gross font student. Right? We're going to assume it's us by ourselves, and we're going to try to do this. So like somebody said, and you guys should all know this, this is what happens. They take a sample. So normally, like, has anybody ever heard of the website Gallup? There's a website that polls people, Gallup. They normally do anywhere from like 1,000 to 2,000 people. They try to randomly select these people so that they'll represent the entire population. So this is a very misunderstood idea. If I took 300 randomly selected gross font students and found that 6% of them thought that parking here was good, would that number go up or down if I took more gross font students? See, that's the thing. I don't know. How do you know? I would guess that it would stay about the same. And I would be, most of the time, right. Sorry for you guys. Especially if I really did a random sample. This is what I don't understand. I think people have less of a feel for what percentages really mean. So if I have a whole population, all a gross font, and what did I say, 6%? So I pick 300 randomly selected. So from everybody, I pick 300 randomly selected students and 6% of them, right? So let me do this backwards. Let's say that in reality, 7% of all gross font students. So 7%, so let's say this group here, that's bigger than 7%. Jeff, good job. This group here, that's still bigger. Screw it. That group there are the ones that like parking at gross font. Right? So if I randomly select students, what percentage of the time will I take a student from in there? 7% of the time. Do you guys see? So I'm going to see the percentage close to what the real percentage is if my sample is good and big. If I take 3 people, no good, Jeff. Do you guys understand? I think percentages are less understood in general. And when I teach algebra, people don't seem to understand percentages as well as they used to. Not your fault. They're just not teaching it as well as they did before. I don't know what's going on. But this is one example of that. If I take more people, this is why mistakes were made, but this is why, like CNN and whatever, they like to say the exit polls say this, and now we're going to predict the state goes to this person. Oh shit, we were wrong. But they feel pretty good about if 98% of everybody has reported, then I can be really sure that what I see is true. Unless that 2% is like every single one of them wanted this other person. What's the chances of that happening? Very small, right? I don't know if you guys are sort of with me or not. I'm going a little bit beyond what I need to now. Don't worry, some of this stuff we're going to cover through the whole semester, because it is misconceptions people have. But right now, all I want you to know is what population means, right? Just to make you feel better. For everything I just said, just know what population means, right? And from that, we take a sample. So what is a sample then? What's one way I can describe a sample? Say again?
The number of people?
It's not really a number of people.
Or the group of people?
So I know I said I took 300 corresponding students. The number is important, but the actual sample is the students, right? I happen to pick 300 of them. Is that cool? Yeah.
Representative of the population.
Be careful. The word sample doesn't mean it's representative. We want it to be representative. Oh, but all I need for a sample is for it to be a subgroup or subset of the population. What do we're doing age, right? For later. So this would be like 300 Grossmont students. Let's make it, you guys are not going to believe me, but too bad. Let's make it 50 Grossmont students. It's actually still a good sample if you do it randomly. And you're all like, what the hell are you talking about? But think about it. Why would people not trust, why do you not trust that? I can see it in your face. How many Grossmont students are there, do you know? About 18,000 right now. 19,000. Did you realize that? You're all like, this morning I did in traffic. That makes sense. So if I pick 50, do you guys believe me that's, if I do it well, that's plenty to be able to say something statistically? If your guys like, well, you're teaching the damn class, I probably trust what you're saying. But it doesn't make sense to people. But think about it. I said earlier, Gallup talks to 2,000 at most people. And how many American people are there? 318 million right now? Hello. Right? But if I pick those 2,000 people, not pick them, but make sure that the process I use is unbiased. So I get a random sampling of people, then it should be representative. This is something, again, this is a part of how we do things, and it just doesn't seem to make gut sense to us. Right? But it is the reality of it. All right. So again, with everything I just said, I just want you to know what sample means right now. The rest of it is going to be something we investigate over the semester. Yes, sir. Ma'am.
Would it make sense for the definition for sample to say that it's like a chunk of the population?
Sure. I know what you mean. I don't, when I give tests and quizzes, I never ask you straight up to define this. So that wouldn't become a problem. If I did, I would need a little more than that.
Is that technically correct?
Sure.
I just need it in lower terms so I can...
Oh, I see. Subset population, subgroup, certain members of the population. Yeah, so if you said that, I'd be fine.
Okay.
So when I do quizzes, I don't do definitions. I make sure you use the words correctly, but I don't say define this. I don't want you to do that. I want you to use it correctly.
So, like, in terms of the homework, I've had to look at it, some of it. They're like, when they have really like simple statements, can you just say like, if you have the population, can you just say like, the sample of the population would be like the people that they surveyed? Can you just? Oh,
totally.
Okay.
So if I said I surveyed 87 Grossmont students, what's the population? And what's the sample? 87 Grossmont. You got. So in fact, be more specific with the population would be all Grossmont students. And then very often, not always, but very often you can, for the sample, just replace the word all with the number. Because that's the specific subset that you're dealing with. I like it. So a lot of the homework in the early going is very simple like that. Some of it not so much, but we're getting there. All right. 2 definitions down. Now, what is it we wanted to say about this?
The average age.
Yeah, so in this case we want to know the average age. Everything up here in parentheses is kind of like the specific thing we're talking about. And now I want to write the definition and the word for this.
Parameter.
Yes, I like it. Somebody's reading ahead and I like it. And what's beautiful about this word is it starts with a P and it goes with population. So parameter is very often, most of the time it's numerical. So I'm just going to go with this. Numerical description of the population. So some kind of an analysis you do. So it could be like an average, it could be a percentage, it could be a median. Right? We haven't talked about the word median yet, but have you guys ever heard the word median? It's kind of big in the news right now for median house prices. Right? So you hear that word. So we're going to talk later about how the median and the average, or what we call the mean, how do they relate to each other. So the parameter is a numerical description. Become an I. There. Of the population. Good Lord, Jeff. I think my summer was too good. I'm not quite back yet. What's that? If it's ever to the point where I can't read it myself, that's when I have to retire. So a numerical description of the population. I did have a teacher that would be like, so you remember what I wrote up here? Oh God, you're here a couple years too long here, buddy. Sorry. Yeah, actually he was. He was kind of. Okay, so that is what I want. Am I going to get a hold of that? How many people am I actually talking to in our example? 50, sorry, the 87 was from something else. 50 gross month students, right? He's like, you keep throwing numbers out, man. I'm sorry, I'm a math guy. So, I can't, this is what I want to say something about, but I'm going to have to use an estimation based on my sample, and the beautiful thing is, we call it a statistic. So parameter is a numerical description of a population, a statistic is a numerical description of a sample. You gotta love that stuff, right? Doesn't happen enough in math. Now I got that Michael Jackson song. Mama say, mama say, mama. All right. So statistic is a numerical description of a sample. So it's a nice analogy there with a parameter. How are you guys doing? So if I said 87% of all Americans enjoy flying to other countries. I don't know if you guys picked up on the word there. Is that a parameter or a statistic? 87% of all Americans enjoy traveling to other countries. It's a parameter. What's the key word? All. So I'm talking about everybody. It must be a parameter because I'm talking about a population. Right? If I said the average temperature, well, shoot, that would be hard. The average cost of books for 27 selected students was $300. That is obviously a statistic because it's referencing a sample. You guys see that? That's relatively simple to get down, hopefully. Some of you guys look a little worried, but don't worry. Okay. But this kind of makes sense. I got to be able to use words to capture ideas so I can talk about this stuff quickly. And that's really what definitions and all that stuff is. When I say population, we all know what I mean. When I say statistic, you all know what I mean. I like it. Blah, blah, blah. Make sure I catch everything. Blah, blah, blah. Oh. So, this is an example of, if I say something like, we take 50 gross month students, let's say I take 50 gross month students, and we find the average age of those 50 students to be 25.7 years. You guys with me? There's a lot of students here that just came out of high school. How many of you guys are like that? All right, and there's a lot of students here on the other things just going back to try to get up higher in their employment. Anybody in that case trying to come back? I don't want to point you out. You're so old. No, I'm sorry. So am I. So, the average, last time I remember, was like 27, something like that. So for my little group of 50, I could maybe get 25.7. So if I said, from our analysis of the data, it looks like the average age of gross one is 25.7. That, of course, would truly be a statistic, but I'm using it to make an inference about the parameter. All right, so I use a sample to get a specific thing, and then I try to say, well, it looks like that is true for everybody because I believe in my sample. I believe my sample is good. So that's what we call inferential statistics, because I'm inferring something about the population from just a sample. So I'm not going to, any of you guys paying any attention to the election, or are you because you can't seem to escape it? But, right? You turn around like Trump, oh shit, and Hillary, oh shit, Gary Johnson. Gary Johnson. Anybody paying attention? So very often you'll see, like when they say it looks like candidate A is going to get 44% of the vote, and candidate B is going to get 43% of the vote. So, on the surface it looks like, well, A's going to win. I wanted B. I'm not going to go. But at the bottom of the screen, you always see this plus or minus 4%. This is an inference. They didn't talk to every likely voter. They talked to a sample of voters. We're going to be able to calculate this number later in the semester. But why do you think this number might go up? What is this number, by the way? What does it relate to?
Margin of error.
Margin of error. So it's how far off they think they are. Even that is given a certain allowance of error within it. So later this semester we'll be able to calculate this. How do you think you're going to make that number go down? I would just talk to more people. The larger my sample, the more certain I should be with what I see. Does that make sense? So if I had a very small sample, this could very easily be 10% or something. But Gallup, for example, figured out from 1,200 to 2,000 people, you get about 3 or 4% error, which apparently they can live with, right? And we'll learn later that is a key thing to say, that's pretty close, that's pretty good. Somebody's semi with me. So I am mixing current things you have to understand with things we're going to talk about later. So right now, I just want you to know what inferential means. Inferential statistics. That's going to be like the second part of the semester. We're going to talk about this. It's the more calculation part. It's not even the second half. It's like the second 3/4. The first quarter of the semester is going to be about descriptive statistics. And this is where we make bar graphs and these things called histograms and pie charts and these things called dot plots and box and whisker plots. Yes, that's the actual name. You guys kind of with me? All right. All right. At least you're all facing this way. That's the baseline for me. Let's see. Blah, 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 blah. Blah, 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 blah. Blah, blah, blah. Okay. So coming back to our little story here. Where are we at? So once how do we get this? When I have my 50 people, we select under 50 people. Actually, let's start there. Let's start there. Let's talk about how I can pick 50 people well. So if I used you guys and like threw a few of you out and made it 50, would that be a good sample to use? You're all Grossmont students, right? Everybody in here, you Grossmont, or are you just bored you came in? What's going on right here? Okay. Could happen. Why would you be a good sample?
No.
Why not? You're not bad people. Why would you be a bad sample?
Because we're all in one class.
All in one class. I love it. Remember, why would you not represent all of Grossmont students? That's a very excellent point. You're all in this one class. That actually holds a lot of things in it. You're in a stats class. Does everybody have to take a stats class? No. You're here at this time of day. Is everybody here at this time of day? No. There are people that only come after 5 because they work every day till 5, right? What else you got, Jeff? I don't know. Shit. It's Monday. Maybe people are here at this time of day, but it's Monday, Wednesday. Maybe they're only here Tuesday, Thursday. Why else would you this be bad, or did I take it away from you, sir?
100 level course?
Good. It's like an intro course. So maybe somebody's coming later, they need higher level courses, or maybe they're only taking developmental stuff right now, so they're not even in any 100 level courses. I love it. So you can see how that would leave people out. So I'm trying to lead you to the definition of random sample, because that's what we want to get. We want a random sample. What would be a definition for that? Oh shit. Don't tell me how to get it. Don't tell me put numbers in a hat. You're right. That would be a good way to get a random sample. Give every Grossmont student a number. Throw them all in this giant hat. Have some little person go swimming around. Get in there. Throwing stuff out. And that would be a good random sample. You guys with me? We're not gonna, let's do it. No, we're not going to do it. What would be a good definition? What is it we're trying to do? We're trying not to do what? We don't want to do what? We don't want to be biased. What does that mean? It's a good word to say. What does that mean? Right now we're being biased. If I used you guys, you're being biased towards all the stuff you said. The 160s.
You fixed it. By being biased, you already know what you're looking for, and you're leading.
Good. So that's why I don't want to be biased, is because if I do that, my stats might lean one way or the other. So I won't get a true picture, right? So if I want to know what percentage of people like chewing gum, and I stand out in front of a gum store, pretend like there's gum stores, right? And I say, do you like chewing gum? I'll probably get a lot of yeses. My analysis says about 98.7% of people are like to chew gum. That's amazing. All right, I like it. So that's a really extreme example of bias, just to make something silly, right? All right, so what should my definition of random sampling be then? What should my goal be? I know we don't want to be biased, but that's not telling me what to do. It's telling me what not to do. Beautiful. I love it. I want to be a truly random sample. Every single element or person in my population, this sounds like a note. Every single element or person in my population has to have an equal chance to show up in the sample. So even Gallup doesn't quite get there because they call people, and what's wrong with that? Unlisted numbers. Does everybody in the U.S. actually have a phone? Believe it or not, no. Does everybody have a computer? No. Does everybody have access to the internet? No. Right? Some by choice and some just because. That's the way it is. Right? Off the grid. All right, how are we doing there? Is everybody with me? So that the definition of random sample is I want every single element or person in the population to have an equal chance to show up in the sample. If I do everything in that direction, then I can trust, even if I only take 50 gross response students. If I chose them in a way that it's true, I'm going to trust my results.
Since we're talking about elections, do you remember that election? It was back, I don't know, in the early 20th century.
In the year 2000 with the hanging chads?
They kicked out and they called and they said, you know, this person is going to win guaranteed because they called from the phone books and they called only people with phone numbers and phone.
Exactly. Yeah. So the data was biased just enough to throw them off.
And they'll put business out.
I know. And they got a little bit carefuler about it, a little bit more careful, but they still try to call elections a little too early, I think. But anyway, oh well, it's all great drama and great theater. Right. This election a little bit more than others. All right. Cool. Where am I at? Blah, 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 blah. Okay, good. So coming back, that's random sample. We're going to talk about different types of sampling later, but I just want to get that out there. That's what a random sample is. It's always our goal. But let's say we do that. So I gave the example to put the numbers in the hat. Anybody have another way we might be able to get a truly random sample of gross response students? Some other way? Okay, good. Real quick, you guys, if I put the camera, can you guys help make sure? If it goes off, let me know. It takes little union breaks. Yes?
If you randomly chose by student ID number.
I love it. So we got student ID numbers already assigned to students. You could get, how would you do it?
Randomly.
But what does it mean? Would you have a computer do it?
Yeah.
You could, and they approximate randomness pretty closely. In fact, recently they made a breakthrough. When you have a computer make a random number, it actually isn't truly random. It has to be based on something. Very often they base it on the clock and some funky calculation. So it's not really random. That's really weird. Some of you guys are like, I didn't care about that, but you had. Right? So they actually made a huge leap recently in the math of how to make more randomness occur. Oh shit, hey. You guys in stats? What's your names?
Not Ahmed.
Do it again, sorry?
Not Ahmed.
Alright. Well, alright. See me after class. Cool. I'll find you. Yes.
I'd like to sample at different times of the day. Since we're talking about different times.
I like it. So you could directly try to control all the variables. So you would take different times a day, different buildings, different classrooms, different times a day, different days of the week. So that would be the long kind of way to go. But it's if you didn't have access to everybody's ID, which as students we wouldn't, right? That would be the direct way, is to try to control for all the different variables, to try to make sure we hit all the different possibilities. I like it. Yes?
You can take into account people's race, ethnicity, socioeconomic class.
Oh, and make sure that every group is represented. I like it. That's incredible. That's a type of sampling that we'll talk about later. Yeah?
Then you take out the oldest, you throw it away. You take out the youngest, you throw it away. And then you just do the average.
Oh, so that's less of a sampling method and more of a...
You find your golf handicap.
More, it's called a trimmed mean. So you're not letting the extremes affect your mean. That's not really a sampling technique, but that is a technique for controlling for what's called outliers, the extremes. Yeah.
Isn't there that random number line thing? It was like, I don't know, it was in the back of our stats book last year.
Oh yeah, okay. So that approximates random. Yes, okay, I got you. They got random number tables.
Yeah.
But those random number tables are generated by computers, and when they create random numbers, they don't really do it randomly. So it's really weird. Anyway, trying to approximate randomness is nearly impossible. But like I said, they recently had this big breakthrough. Google it. I'm sure nobody will, but it's the only job. But breakthrough in random approximation, you'll get it. All right, I'll stop. Okay. So coming back, once I get these 50 gross fund students picked, what's my very next step considering where we want to get to? What am I going to do next? I got my 50 students. Say, you guys are my 50 students. I've selected them from all different classes, all different times of days, and whatever. I'm probably going to have to do what first? How old are you? Or you didn't show me your ID, so I know you're not lying. Right? You guys. So somehow I got to ask them a question, and then they have to give me an answer. It's amazing, right? You're like, well, of course, Jeff. What the hell is your problem? But those are two important steps because they relate to two key ideas. The question that I ask is related to the variable, and the answer you give me, the whole collection would be the data. Of course, right? Does that make sense? So the question I ask is related to the variable. The answers I get are the data. That seems really fundamental, but I don't know if you ever thought about it that way. It makes it very simple. If I say, what's the variable? You say to yourself, what would the question be? Right? So if I said I wanted to find out what percentage of students drive BMWs, what would the variable be? Think to yourself, what would the question be that you asked your group of students?
Do you drive a BMW?
What kind of car do you drive? If you say, do you drive a BMW, that'll also get to it. I love it. So you can say yes or no. But the what kind of car do you drive allows me to make further analysis later, right? But still, you're right. That's exactly right. I love it. But see, so in that case, I didn't define it well enough. I would take either answer. But do you understand how to think about a problem now? I mean, if I say, what's the variable, you think, what would I ask the people that I picked to get to what I want to get to? That's how you go about it. And then I say, what's the data? You say, what would the answers be to that question? Right? So yours would be yes or no. That would be what your data would. Yours would be Hyundai. I just like to say Hyundai. Hyundai, whatever. Right? That's all I can think of right now. That's the only car that exists for me right now. I don't know. All right. Okay, so real quick, just to capture that, question is related to the variable. The answers make up the data. Okay, I like it. Okay, cool. All right. So just a little bit more today, just to let you know, because I know the definitions get a little bogged down. We're going to real quick talk about different types of data. And there's a few different ways to kind of break them up. There's one main way between two groups, and then I can break it up into 4 different groups. So we're going to do the 2 groups first. I think actually even, can I throw in there? Oh yeah, I can throw that in there too. Cool. And this might be it. I'll let you out nice and early. Don't get too excited. Not the next 5 minutes. So one main way, there's 2 main types. Yeah. And I don't know if you have the book. I'm sort of on page 14. And to be honest, if you have the page numbers are different if you have the physical book and the online book, and that's great. So I apologize in advance. 2 main types of data. There's quantitative. Can you spell, Jeff? I don't know, Jeff. Quantitative, and there's qualitative. What's the root word of quantitative?
Quantity.
Quantity. So quantitative must reference what type of data? Numerical data, something I can actually, the quantity of something. There are 4 doors on my car. That's the quantity of doors. So this is truly, I use the word truly on purpose here, truly numerical data. Qualitative, the root word is quality. That would be some kind of characteristic like hair color, even your name. So this is what kind of data? This is, I kind of gave it away a little bit. You can call it name data, categorical data. You can categorize things, right? So this is non-numerical data, but this is categorical. So where would your social security number, where would that fall? It would actually fall qualitative, because it's sort of like your name in a way, right? It's not truly a number. If I think of the difference of two social security numbers, does that actually tell me something truly? No. So like if I take the difference of two zip codes, does that tell me something? No. Right, 1 year, like jersey number, which one would that be? Qualitative. It's like your name. There goes number 14 as a way to reference you. I can categorize you by your number. You are the 14 person. 1 year I had members of the women's basketball team. And I said, what's your jersey number? 14. What's your jersey number? 12. I said, if you take the difference of those, what do you get? We get Michelle. She's number 2. I was like, oh, shit. I was like, all right, crap. Just me. That would happen too. So that's that. That's pretty straightforward. You got to love that. Quantitative, it gives it away. That's what I meant by truly numerical. The numbers don't necessarily mean they're truly numerical, because they could just be another name for something, right? So I can kind of break these down in an imperfect way into 4 subgroups.